I want to explain the recursion with an example that you can see every day. And these are trees. Here we have a tree. I want to explain how the tree grows its branches, because this growth of branches is very similar to the recursive method of growth. In this case, we talk about the wooden parts of the tree. We don't talk about the leaves. Instead, we talk about the trunks. I have marked them here, and I want to show how this works. We start with the given trunk. And now we add 2 branches for every function. One small branch with a 45-degree angle at the left, and the bigger branch with a 45-degree at the right. So, this function will be called every time for a new created trunk. And this means if I might look at this new branch at the right, and consider it as a new created trunk, then the function which describes the growth of trunks will be recalled. That means, again, there's one small branch with a 45-degree at the left and one bigger branch with a 45-degree at the right. The overall size of the new branches is a little bit smaller than the overall size of the new branches in white, because the trunk is a little bit smaller too. And like this, we move on. I have gotten 2 new branches. I will make the new one on the right green, and again I will recall the function. I got one small branch with 45-degree at the left, and a bigger branch with a 45-degree at the right. And I could continue this procedure endlessly. But I don't want to overlook the new trunks on the left. Until now, I have only used the function in the right-handed side. But I have these trunks on the left too. These follow now. So here was my new trunk on the left, and this one also gets a smaller branch on the left, and a bigger one on the right too. And these 2 trunks will also be seen as an input for the function. With the result that I will get a smaller branch on the left again and a bigger branch on the right. A smaller branch on the left and a bigger branch on the right. And I can repeat this procedure every new branch. Also for the new green trunks. And this means it would branch endlessly. Until it gets so detailed that no more branches could be seen anymore. But I think the principle is nicely visible here. I call the exact same function with the same structure over and over again. Only the input changes, the trunk size and position. And according to the end position of the trunk, I add 2 new branches. Every time the same degree, the left one a little smaller, the right one a little bigger. And now I have a trunk-like structure. And if you want to simulate nature in a computer visualistic, for example trees, we use this recursive call. So we recall a trunk growth function again and again with itself, and the new created branch parts, so that we get a tree because we found out that we could copy nature very good like this. In software engineering, recursion isn't used very often because the feeling occurred that you could solve everything with iterations. But we should look anyway what it means if we have an algorithm that works recursive. Here I have prepared one recursive and one iterative working algorithm. First, I want to talk about the iteration. You could say it's a normal for loop. We will see how this works. Here I have prepared a pseudocode function. Its name is simply sum1. And this function sum1 gets a number and should only add all numbers until this number e. It should make the sum of all numbers smaller e, including e. For example, if I would have to start the function sum1 of 5, then I would get 0 plus 1 plus 2 plus 3 plus 4 plus 5. That would be 15. What we would get at the end, and this function works pretty simple. What we have here is a sum variable. It will be set to 0. And then I am going with a for loop and a counter variable I over the numbers until my ending number. I will be set with new numbers. And here in the body of the for loop, I've got my sum variable, which is always increased by the number I. And it starts with I is 0. Then it says the sum matches 0 plus I, because I is equal to 0, sum stays 0. Then I becomes 1, and then it says sum equals sum plus I, which is now 1. And so on. This for loop uses a runtime variable I with the numbers from 0 until and inclusive ending number e. And we go through here and add every time on top of our sum variable the actual value of the runtime variable, and at the end return the sum. This is called iterative calculation of a sum. Seems easy and understandable. Now I want to show you how this works with a recursive variant. So, this recursive function works like this. We also get the number e when addressing the function. In our case, that's 5. And now we do it like this. If the given number equals 0, it returns 0. Else, the function would recall itself. This we can see back here. Here is written, call yourself again, but as an argument. E is not used, instead e minus 1 is used. And now the function will start again. We start again in the first line. We look if the new e is already 0. If not, the function will be called again. And we see that at this call it will always say, okay, whatever is returned by the function will be added to the e variable. Because of the difficult understanding, I want to demonstrate this to you. And we will begin with the first call. We already said that we would call the function in our main method with the argument 5. So we start. We look if e, which is now 5, is 0. No. So we go down here. Here stands return e plus something, and this something has to be calculated before the return will be executed. And at the calculation of this second term, sum2 open bracket e minus 1 will recall the sum2 function. then that's a recursive call. But now the sum2 function won't be called with the argument 5 again, but with the argument 5 minus 1, meaning the value 4. Now a new sum2 function will be started. It will be checked again if e equals 0. Now e has the value 4, so it isn't 0. Thus we are entering the lower part again. Again, the current value of e, which is 4, will be added to something that needs to be calculated first. For this calculation, the sum2 function will be called again, so this is the next recursive call. Sum2 of 4 minus 2 results in 3. This is how it's going on and on. We go to the function sum2 of 2, and then we go to the function sum. 2 of 1. And the sum function, 2 of the argument 1, does exactly the same like all the other predecessors too. Looking, if e equals 0, what it isn't because e is 1, so return 0. Going into the else branch, and there's now return e plus something you need to calculate. So the sum2 function will be called again. Thus we are having here again sum2 of 0. Now the sum2 function will be called passing the value 0. E equals 0. With this value we are entering this body, and we are returning the 0. This 0 will be returned now, and if we remember, we know when we call the sum2 function with the argument 1, the sum2 function has been called here below again with the argument 1 minus 1. Now the function here returns to 0 now. Currently we are on the sum2 function with the argument 1, meaning e is 1. So this function will return 1 plus 0, which is 1. So we are getting a return of the value 1 to the function called before this one. This was the sum2 function using the argument 2. The sum2 function with the argument 2 receives a 1 now. It's calculating 2 plus 1. This is 3, so it returns 3 to the function called before this one. This function now receives a 3 and calculates 3 plus 3 equals 6. And the function before receives the 6. Since it was the sum2 function using the argument 4, it calculates 4 plus 6, which is 10. Now we basically return to the first of all sum2 calls. This call has received e with the value 5. We found out that the second term here returns 10, so the function calculates 5 plus 10. The result is 5 plus 15, which is correct. This was a recursive call. Certainly you have seen that this is a little bit complex and harder to calculate than the iterative calls. That's the reason why they are used very rarely in practice.